everyone, in this lesson I'm going to show you how to use Excel to create a quadratic regression model. The data that I have here was contained in a news release from the Insurance Institute for Highway Safety, and it gives the number of motorcycle deaths for cyclists aged 30 to 39 from 1901 to 2000. The very first thing that we need to do when we create a regression model is to build a scatter plot. So in order to do that, we need to decide what our input and output are. So our input here is going to reflect the year. And when we put the input into our Excel file, we use the number of years since that initial year that we are looking at in our data set. Why do we do that? Well, we let the input values be the number of years since 1991 because this is a snapshot of the data that we're looking at. 1991 is that initial year, so it should really correspond with the y-intercept. So if we let 1991 be year 0, that's going to be the first year of data that I am looking at. Also, using the scaling of numbers since gives us a model that has smaller, easy to work with coefficients and a constant. So in my Excel file, I'm going to label my input column, which is column A, number of years since 1991. Column B is going to be number of deaths. Now I'm just going to input the data. So again, I have year 0 is 1991, year 1 is 1992, and so on. Always make sure that you're looking at what years are actually in your data set, because if you have years that say skip a little bit, you are going to have your input values skip a little bit, because it all should be scaled appropriately. My output is number of deaths, so I'm going to type in exactly how listed. So we notice when we're typing in this data that at first we see this decrease occurring, and then somewhere around the year 1996, 1997, we see now the data starting to go up again. We see an increase again. So we know right off the bat that this data is not going to have this linear correspondence. So we don't see, the data increasing only or decreasing in general only. We see that there's actually a decrease and then it starts to go back up and increase. Okay, remember when we are building a model in Excel, the first thing we need to do is highlight everything, including those labels at the top. Excel always looks for the labels, so don't forget to actually label those columns for what they are. We're going to go to Insert, and then you should see something towards the middle of your screen that looks like a scatter plot. And you see XY scatter when I just lay my cursor over it. Okay, so this is what we should see. When looking at the data, just like when looking at the column, we saw that we decreased and then we increased. So this is not linear data. This has more of a parabolic shape, meaning that it's going down and then it's going up. So the next thing that we want to do is find what model is going to approximate this the best. So we're going to use a parabolic model or a quadratic model. So I'm going to right click on any point, it doesn't matter which point, and I'm going to add a trend line. We then get all these options here. So I want a polynomial of order 2, which means the degree is 2. Then at the very bottom of this menu, I see display equation on chart and display R squared value on the chart. Remember that the R squared value is a statistical measure of how well a regression line approximates real data points. So it's just a descriptive measure. It's always between 0 and 1. And the closer that we are to 1 is the more accurate the model is with respect to the data. So here we're at 0.899, so it's not a perfect model, but it's a pretty good model that it does get close to most of the data points, especially towards the center. So there's a greater ability for this model to predict a trend. From here, we can now use this model in order to create a prediction. So if we are using this model to predict a value that is within our data set, so I want to see how good my model is based on these values, it's called interpolation. But if I want to see, what would be the prediction for the number of motorcycle deaths in 2019, that's called extrapolation. I'm finding something that's outside of my data point. So I'm really using this model as a prediction tool. So part C of our questions here that I have is, in what years will the model predict that the number of deaths of motorcyclists will be 1,000? So the equation that I'm solving is this regression equation. So I'm going to round it to 1 decimal place. X squared minus 67 times x plus 717.3. I want to know when that is equal to 1,000. So one of the easier ways to do this, we can solve this using Excel, but it may be easier to solve it using the graphing calculator. So you have a choice in how you want to solve this. If I'm going to use my model here, what I'm going to do is create a second chart. And you can make it as large or as small as you want. I see at year 9, based on my data table, so that's in the year 2000, there's 687 motorcycle deaths, and we see that it's going to be increasing based on the regression graph. So I don't think it's going to take too long to get to 1,000. So if you want to type this into Excel and have Excel come up with the table, we need an equal sign because that starts off the formula. And then we're going to input our information. So 6.9 times this input value squared minus 67 times, again, the same input value, plus 717.3. And then hit enter. If you did it correctly, your very first value should actually be the y-intercept, which is 717.3. Now what's nice about Excel, if you don't know this, is that you can drag and it will continue this pattern of using the input value and pre-fill in the formula. So we have 6.9 times 1 squared minus 67 times 1 plus 717.3. Okay, you could do the exact same thing in your graphing calculator by going into y equals, setting this equation into the y equals, and then looking at the table. So I see it's pretty much between year 12 and year 13. So if year 9 is 2000, 2001, 2002, 2003, looks like around the year 2004 is where we are going to predict that the number of motorcycle deaths will be about 1,000.